the top, the highest, lowest to the highest. So the lowest, you see the graph is going from -5 and up to +5. Well, since we're talking about the range, we're looking at the y. If it asks for the domain, then you will look for the x, but this one is the range. So it's from -5 to +5. -5 has an open circle, so we don't close it, which means it's not included in our answer. No, in our range. Okay, let me go to the next question. Given the function f of x, or function below, so f of x function is graphed for us, what is f of 6? So this is a um, function notation. What you should know that this is equal to y, okay? And this right number here is your x coordinate. So basically you're just looking for when your x is equal to 6, what is your y coordinate equal to? 6 as well. Okay, so f of 6 equals 6. Basically you're looking for this coordinate 6, 6. Here's how you would read it. X is 6 and y is at 6 as well. Okay, this one. It says let f of x equal x and g of x equal 4x plus 2. Choose the two correct statements below to compare the graph of g of x to the graph of f of x. Alright, so let's go ahead and again there's also two ways you can do this. I'll show you the graphing way first. I am sorry, I already have the answers on here, up and steeper. I'll show you how that is so. So we're going to go ahead and put f of x equals x. So this right here is the parent function. If I go in, you'll see that it has a slope of 1 over 1 or just 1. And it goes right through the center. So this is f of x equals x. And then we have this other function here, g of x equals 4x. Before I type the plus 2, let me just look at 4x. Well, it got steeper. It's when it's steeper when your graph, let's do this, when your parent function right here, which is just f of x equals x, is steeper when it goes closer to the y-axis. So if I had the y-axis right here, okay, a steeper function would go closer to the y-axis. Let me just draw a full. Okay, so here's f of x. A steeper function would go closer to the y-axis. It would just go move closer to it like that. Okay, that would be steeper. If it was less steep, on the other hand, if it was less steep, your function, so let's compare it to the parent function again. It would be less steep. That means it will go closer to the x-axis, meaning it's going to get pushed down like this. So this is steeper and this is less steep. And in our graph, we can clearly see that it's steeper. So the graph of g of x is steeper than the graph of f of x. It also has another type of shift. The y-intercept goes up. Okay, so that's how you can tell if the graph itself is going up. Even though it looks like it's shifted here and there, the easiest way to find the parent function shifting up is to just look at the y-coordinate. So if I look here, I'm going to go ahead and put this up too. And here's the y-intercept, and here's the other y-intercept. It shifted up too. So it not only, the graph not only became steeper, but it also shifted up. So that's what we have there. Okay? That's one way to do it. Oh, and then if the graph shifted down, so again, you have your parent function right here. And if the graph shifted down, it doesn't matter if it's steeper or less steep, it would, the graph would just, the y-intercept, oh, I totally missed a y. So the y-intercept, I'm trying not to draw a line that's parallel to it. So let's draw like that. That looks really ugly. But anyway, it gets shifted down. Okay, just look at the y-intercept. So you're like, if you're wondering what the answer is, it's shifted. So whenever I use the word shifted, just know that I'm talking about the y-intercept. Is it just the graph go up or down? And you can clearly see it using the y-intercept. Let me show you one that shifted down. I'll just do shifted down 3 units. Oops. If I put a minus sign, then you see how the y-intercept shifted down. So that's how you can tell the shift. And then we saw that it is steeper because it went closer to the y-axis. Okay. There is another thing that I wanted to kind of tell you about steeper and less steep. For steeper and less steep, we always use the value of the slope. Okay, so for steeper and less steep, we look at the m, or the slope. For it moving up and down, we look at the y-intercept. Okay, so these are two different things we're looking at. Even though these two work together to give you the line, the process of finding and analyzing, they are completely two different things that we need to look at separately. For the slope, if you have, for things to be steeper, if you have any number between, let's say, -1, not between, let me start with steeper, yeah. If you have any number that's greater than 1, so if your number or your slope is bigger than 1, then it's going to be steeper. So like 2, 3, 4, 5, 5.5, 5.6, any number that's greater than 1. Okay. You could also look at any number that's less than -1. So like -2, -3, -4, -4.5, numbers like that. They're going to be steeper. For numbers that are less steep, it's going to be any number between -1. So m has to be between -1 and 1. So it would be any number that's like a 0 point something. So like 0.5 or like 1/4. If the numerator is smaller than the denominator, it's going to be less steep. Okay. If you're not able to remember those specific rules for it, you can always just graph it and check. As long as you know what the graph steeper and less steep look like, then you should be good. Okay. Up and down. Up and down is a lot easier. It's just that if your y-intercept is positive number, so if your y-intercept is positive, you go up. If your y-intercept is negative, then it shifts down from the parent function. All right. All right, number 5. What is the equation of the line that passes through the points 1, 6 and 4, 3? So let me just go ahead and ask you, or show you what this question is asking. So we have 2 points. There's the 1 point right there. And the other point is -4, 3. Let me zoom out. So there are my 2 points. I like to have my Desmos screen kind of zoomed into where I see the 5s, because then I'm able to count the boxes to get an accurate count for the slope. or for the y-intercept for that matter. Okay, so we want to see which one of these equations goes through this line. Now, I could just go ahead and graph each one and see if which one works. Let me take a guess here. I know it's a positive, so it's going up. And then my slope is 1, 2, 3 over 1, 2, 3, 4, 5. So up 3 over 5. So I think it's between C and D. And then the other parts, I'll show you what to do. Okay. There are 3 different types of ways that I can write an equation. Our favorite way that we've seen written in class is the slope-intercept form. So right here, the slope-intercept form is y equals mx plus b, where you can have the slope and the y-intercept, you plug those in, and you have it. But it doesn't look like that's the form that I have here. The second one is the point slope form. That looks like what it is. So it's actually a pretty easy form. It's asking you to take y and then put a y coordinate right there. And actually we're allowed to use either one. I could use this coordinate or this coordinate to give an equation of that line. Minus the slope times x minus the x coordinate of that. So it looks like we're definitely using this coordinate right here. Okay, so I found the slope, which was rise over run, so 1, 2, 3 over 1, 2, 3, 4, 5, 3 over 5 between C and D. I could also, use the slope formula if you'd like, if you're used to the slope formula. 3 minus 6 over -4 minus 1. And there's my slope. That's another way you could do it. And then we're going to go ahead and use this point. So my y is 3. So if I'm going to use this, you're going to put y minus the y coordinate, 3, equals the slope, which we found to be 3 over 5, times x minus the x coordinate. So minus -4 would be positive. Oh, if I did that too fast. Minus -4 would just be negative, negative just turns into a positive. Positive 4. And so it's D. Okay. Also, you could always just graph, and if you're given a multiple choice, you can graph it, but that's if you're not given a multiple choice, then you really need to know how to do this um, by knowing the form. Well, there's that. There's the point slope formula. Okay, I have an equation of a line that passes through the 2 points, and it's just written in point slope form. All right, next question. What is the equation of a line that has a slope of 2 over 3 and that passes through the point -2, -3? All right, so for this one, you know that was written in slope-intercept form. So if I'm able to find what the slope is, well, I do know what the slope is. It tells me that the slope is 2 over 3. And then if I know what the y-intercept is, then I can write my equation. All right, so to find the y-intercept, I'm going to start with the slope-intercept form again. And then I'm just going to plug in the given information. I know what y is because it's the y-coordinate of my point. So y is -3. I know what my slope is, which is 2/3. I know what x is, which is -2. So these two, remember, you multiply them together. And I do not know what b is, so I'll keep that still like that. So 2 over 3, let me just put that part in Desmos, times, numbers are being multiplied, times -2. And then go ahead and turn it back into fraction. So this part right here is -4 over 3. I'm just going to bring everything down. And then we can go ahead and just move this over. Add 4 over 3 on both sides. Okay, so that crosses out. And then you're going to have here -3. I'm just going to put this part in decimals as well. And I'm adding this time 4 over 3 and -5 over 3. So my slope is positive 2 over 3, and then my y-intercept is -5 over 3. There you go. All right. All right, number 7. A line with an undefined slope passes through the point -2, 5. What is the equation of the line? So an undefined slope is a vertical line, okay? And also a vertical line, whenever the only way you're able to draw vertical lines is when you put an x equals any number. Like for example, I have a vertical line right there, see? At 4. Ignore the 0 for now, but that's x equals 4. Um, Here's another one, -1. So anytime I need a vertical line, it's always going to be x equals. And if you wanted to go through this point, just pick the x coordinate of that. So x equals -2 would actually go through this point. Let me show you. So -2 comma 5, and then we are going to well, I'm going to show you that that's good. There's a vertical line. I mean, again, it's a vertical line because it's an undefined slope. That's vocabulary you should remember. And it's going through that specific point. So x equals -2 is my answer. Okay. If it said a line has 0 slope, then you would do y equals and then go from there. Okay. Well, let me give you an example since let's say that you have a line that has, I'm just making up an example, that has a 0 slope. So in your mind, you're going to say, well, 0 slope is a horizontal line. And the only way you can get horizontal line is if you put y equals some number. Those are the ways you can get horizontal line. And passes through, passes a point -5 and +6. Well, this is just another example I'm making up here. Well, if I want a 0 slope, then I'm going to have to do y equals and just choose the y coordinate right there. That's it. Y equals 6. So that's y equals 6, and it's going to pass through that point I just made up. See? It's going to pass through that point, and this is and these are my answers. These are the equations. So equations of horizontal lines and vertical lines, just have to remember undefined slope, vertical line, x equals 0 slope, horizontal line, y equals. Okay? All right, number 8. Given the graph of the linear function, select each equation that represents this function. All right, so I have to multiple select. There's many ones I can go through, and instead of me just graphing each one and just checking, which I know you know how to do it, let me just show you what my starting point to find the equation of a line will always be. Is to find the slope, so that's up 1, 2 over 1, 2, 3. So that's the slope 2 over 3x, and then choose the y-intercept, which is at positive 4. So this is the equation of the line. Let me graph it for you and show you that I know how to graph the equation of a line in slope-intercept form. That's That's that. See, it's going through 4 and has a slope of up, up 2 and over 3, just like this has up 2 and over 3. And so that's my first one. From here, usually what we do is we convert this into a standard form. So to convert it into a standard form, we always multiply both sides by 3. Both sides by 3. So that would be 3y equals, and then you distribute this. So 3 and 3 cancel out, so you just have 2x, just the numerator part there. And then 4 times 3 is 12. And then what I can do is I can go ahead and take the x term over. So I'm converting this into standard form. Plus 3y equals 12. Sorry guys, 1 second. Alright, so this is almost in standard form. The only thing is that I don't like this negative. Well, I don't mind the negative, but in general, we don't want a negative in front of the x. So we're going to go ahead and divide out that negative by just doing -1. So this just turns into a positive 2x, and then minus 3y equals -12. So that's a y. Here's another one. So those are both equivalent. Let me graph it for you and check and show you. Again, if you want, you can just graph each one in Desmos and just match it, but this is the other way you do it. And then finally, the last one, it looks like it's the point slope form. So the point slope form, if you remember, has the slope here, and then we use one of the coordinates to find the point slope form. So let's see, this coordinate right here, just take the opposite sign, because the point slope form has it like this. Okay, so the negative just means just take the opposite of it. Okay, so if I take the opposite of -3, for the y coordinate, that would be +3 and then +6. Let me just check if this is a point on the line. So +6, it's not even on here. Okay, so it's not going to be on the line. So let me find what the point is here. X is +3, y is +6. So +3, +1, 2, 3, 4, 5, 6. Yep. It looks like this one works. So these are the 3 lines, equations of lines, and I just worked it all out for you. So let me finish graphing this. Again, that works. So these are the equations of line. But the starting point always really is knowing how to get this, at least the slope-intercept form. Okay. All right, number 9. What is the slope of the line that is parallel to the line of this? So parallel means they have to have the same slope. Okay. So I need to find the same slope as this. Again, as always, there's 2 ways to do this. One, algebraically. Second, put this in slope-intercept form. So just move the x term over. So that's 7y equals -3x plus 10. And then divide by 7, divide by 7. So you have y equals -3/7x plus 10/7. So once I do this, I can tell what my slope is, which is -3/7. And since it has to have the same slope, so that would be my slope. Okay. Another way you can do it is you can take your equation in standard form and you can graph it in Desmos. Desmos does a great job of graphing it. And then you can figure out the slope from here. Now, I should warn you, don't use these points right here because they're decimals. It's just not how it works. So if you want to calculate the slope, just go ahead and zoom out. Make sure to get the fives in here and then find 2 points. So for example, this point right here and this point here. So I can do -1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. Down 3 and over 7, which is what I have here, down 3 and over 7. All right, oops, let me get my graph nicely situated. All right, let me go to the next question. Which is the equation of the line that passes through this point and is perpendicular to this line? Now I have this line here. Let me graph it for you. Over x, 1 over 3x plus 8. I have this line, and I'm looking for a line that's perpendicular, meaning it's cutting the graph at exactly 90 degrees. For that to happen, I need to have a slope that is the opposite side. So since this is positive, the slope would have to be negative, and then reciprocal. So the rise becomes run and the run becomes rise. So 3 over 1. So that would just end up being -3. So the slope will be -3. And it has to pass through this point, -5, 3. So let me put that here. Actually, we're almost done because it's in point slope form, so we can just plug those numbers in. So it has to go through here. All right, so we have the slope, which is at -3, so between B and C, and then we have this point. So let me just write it out first. Actually, it's easier to just write it. So y minus the y coordinate, which is 3, equals the slope, which is -3, times x minus the x coordinate. So minus -5 will make it a +5. And that is the last one. Let's check our graph to see if it works. So y minus 3 equals -3 times x plus 5. There you go. It's very perpendicular, and then it goes through that point. Okay, that's that. A couple more. Okay, so this one, it's a word problem. It's been a while since we've done word problems in class, but let's see what we have. So Tina babysits after school and charges a flat rate of $3 plus $5 per hour. Let H stand for the amount of hours Tina babysits, and W stand for the total amount of wages that she earns. Which graph corresponds to the situation described? All right, so it looks like Tina starts with a flat rate of $3. So this actually will end up being your y-intercept. So you have your starting rate at 3, starting flat fee at 3, and then this right here is your slope. Is per hour. So depending on how many hours Tina is babysitting, this is your slope. So this is your slope. Slope is $5. And then your y-intercept here. Okay, this is your y-intercept, your initial point or your starting point. So it looks like it starts at 3. So this one starts at 3, this one starts at 5, 5, and this one starts at 3. So these two. And then it looks like it's a slope of 5. So it's going up 5 and over 1, up 5 and over 1, up 5 and over 1, up 5 and over 1. This one is going up 1 and over 5, up 1 and over 5. So here, the slope is 5 over 1, and here the slope is 1 over 5. So it's definitely this one. Okay? Alright, and then the last one. Aaron counted the number of cars in the parking lot during a school day. The graph shows the number of cars as a function of the number of time that has passed. Sorry, I already have the answers here again. Complete the sentence to interpret what the zero of the function means. Now you know that the zero of a function is always the x-intercept. Okay, so the x-intercept here is at 10, and at 10, okay, there are 0 cars left in the parking lot. After 10 hours, so the amount of time has passed. So, like when he first looked at the parking lot, there were 20 cars. As time went on, the number of cars declined so much that after 10 hours, there were 0 cars. That's what we call the zero of a function. Alright, guys, that was the last question. Thanks.